Hello, Pre-Calc Math 2412 students. Here's part 5 of the basics of trig for calculus. The last two trig functions, we're going to define them. So we need to talk about an angle and its complement. They should add up to pi over 2 or 90, right? And anytime we put an angle in standard position, theta increases from the positive x-axis up to theta, that's true. And in the first quadrant, you can see theta prime would be right there, right? Theta and theta prime, they add up to 90 degrees. Okay, so this being theta in here, this being the triangle OP sub theta, Q, that's supposed to be a P sub theta there, right? OPQ theta, that's been our triangle we've been using to figure out the cosine and sine of theta, the coordinates of P sub theta. All along there's been this angle theta prime out there, the complement of theta. Well, if you draw the tangent line at T, which is a fancy name right now for the point 0,1. Okay, the tangent line to the unit circle at T, that makes that a right angle. And you can think of the complement of theta has a tangent line across from it. In fact, the function we're about to define used to be called the tan of the complement, or the tan co of theta. Well, they moved the letters around and just made that cotangent of theta. The cotangent of theta, short for the cotangent, the tangent of the complement of theta, really, is that length of the tangent line across from the complement, basically carved out by theta. If theta was bigger, the cotangent there would be smaller. If theta was a smaller angle, that cotangent would be bigger. So the length of the line segment u theta to t is our cotangent of theta. So now looking at that right triangle, OUT, if you could imagine pivoting it around, rotating it around T, that vertex T, right? So if I rotate that around and then move it over here, plunk it down, I have this triangle right here. There's the T with the right angle. Here is O. As far as OUT is concerned, the angle at O is theta complement, and the angle at U sub theta is theta, right? So we just rotated that guy around, shifted it over here. I've taken out the OPQ and put it over here. You will notice that they are similar triangles. They share thetas here at O and U sub theta. They share theta complement at P and at O. So the part of the tangent line cut out by theta on the by the complement of theta, the cotangent of theta, is this length right here. If we're in the first quadrant, it's positive. The cotangent of theta will be the length of the side u theta t. What was OT? OT is the distance from the center of the unit circle out to a point on it, so that length is 1. Okay. And just as we had a secant before, associated secant line associated with the tangent of theta in the previous video, here we have a cosecant line. We're thinking the same secant line, but what does it have to do with the complementary angle? Well, if this is the cotangent of theta here, that chunk of the tangent opposite the complementary angle, this length here is the cosecant. The part of that secant line, same secant line, cut out or associated with the complement of theta. And that would be from O to U. And so you see it out here. So we have, if we just slap some labels on here, some names of these things based on this geometric picture, Now use the fact that the triangles here are similar. We get that the cotangent of theta will be to 1 as the cosine of theta is to the sine of theta. We'll get that the cosecant is to 1 as 1 is to the sine. And therefore, those are now going to be our definitions of the cotangent, the cosecant, for any angle, even if it's outside of the first quadrant. Okay, that's going to be our definition. Cotangent is cosine over sine. Cosecant is 1 over sine. All right, well, this picture here not only gave us this definition, but it's also giving us some identities. I forgot to mention last video, when we had the triangle that defined the tangent and the secant, that thing looked like this. So we had a 1, we had a secant of theta here, we had a tangent of theta over here, and that's a right triangle. So 1 squared plus tangent squared is equal to secant squared. That's called the second Pythagorean identity. Application of the Pythagorean theorem to this triangle. Right here, the triangle OUT is a right triangle, so cotangent squared plus 1 squared is equal to cosecant squared. That's known as the third Pythagorean identity. If this is the second Pythagorean identity and the third one, what's the first one? Oh yeah, cosine squared plus sine squared is equal to 1. That's your numero uno Pythagorean identity. Here's another relation. The cotangent of theta is, we just found here, it's going to be defined as the cosine over the sine. Notice that that is the reciprocal of, it's 1 over the sine over the cosine. But the sine over the cosine is a tangent. So here we have an amazing relationship. The tangent and the cotangent are reciprocal. This is true of no other two trig functions that share the same root. The cosecant is not equal to 1 over the secant. The cosine is not equal to 1 over the sine. Not, that's a not there. But the cotangent is equal to 1 over the tangent. Let's take an example of calculating a cosecant of 7 pi over 6. Okay, so this is how a calculus student who's doing well, you'll see how they'll calculate that. You don't run to the calculator, that's going to give you some approximation. So the cosecant, what's its definition? It's 1 over the sine of the angle. So first of all, we need to find the sine of 7 pi over 6. Where is 7 pi over 6? Well, there's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6 pi over 6 is 1 whole pi. Go 1 more pi over 6, there's 7 pi over 6. It's in quadrant 3. So we draw that a little right triangle there. We say, oh yeah, that's a 30, 60, 90. So the x-coordinate has to be negative, and it's a square root of 3 over 2. The y-coordinate has to be negative because we're in quadrant 3, and that's that short leg. That's that distance there. So that's a negative 1/2 as the y-coordinate of p sub 7 pi over 6. So for the cosecant, we needed 1 over the sine. We just found out the sine was negative 1/2. Therefore, the cosecant of 7 pi over 6 is 1 over a negative 1/2, or a negative 2. So notice that to find one of the 6 trig functions of some not immediately obvious but special angle, we don't pull out a chart where we've memorized a bunch of things. We simply draw the angle in standard position, find its x and y coordinates, therefore know its cosine and sine. And for any of the other 4 trig functions, the tangent, the cotangent, the secant, the cosecant, those are all expressed in terms of sine and cosine. And so all we need to find any of the 6 trig functions anywhere on the plane is a drawing of the angle in standard position and figuring out what the cosine and sine are there. Okay? You should practice this. Make a pile of 6 cards. that have the 6 trig functions written on them. Make a pile of, let's see. So there's 17 special angles as you go around the unit circle. You could make a pile of those, all the multiples of pi over 6, all the multiples of pi over 3, all the multiples of pi over 2, all the multiples of pi over 4, and shuffle. So you have 2 piles, a pile filled with angles written in radians, and a pile of 6 cards for the different trig functions. Just pick a trig function, pick one of those angles out of that other stack, ask yourself some random question like, what's the cotangent of 7 pi over 3? Okay, good luck.